All right, last time we started talking about variables, put one or two in our program. We'll take a look at that in just a second, but let me review that because this is one of the most important parts of this beginning programming class is understanding variables, understanding types. We're going to expand on that a little bit today. Whenever your program needs to store something, and that comes from your design. If your design says on the left-hand side in the calculation module or any module, method. Okay. If there's a variable on the left-hand side, I can tell that these are variables because they do not have labels or text boxes or any of that kind of stuff on them. Those are variables. They store data. We take what's in the date picker, put it in there. We take what's in this text box, put it in there, store it so that our program can use it. When your program, I shouldn't even say if, when your program needs to store data, it's stored in a variable. Variables are named memory locations. Windows gives your program a memory location, assigns it to your program. We assign that memory location a name. We refer to them as variables. We have to tell our program that we need a variable. Whenever we need a variable, we first have to designate what type of variable do we need. Basically 5, 6 types. If you need a whole number, you ask for an int. The ones with the stars. In my notes, there's others. That's just to let you know they exist in case you see them in other examples or you're Googling something and you see this variable type byte. That's nice. Most people don't use them. They stick with integers. So we just do int if we want a whole number. If we want a number with decimal places, we use double. Unless it's money, then you use decimal. Decimal is typically used for monetary values, but it can be used for any floating point number. So in our meters to yards program, technically we could use a decimal, but usually use a double, unless you need extreme accuracy, and with money we want to be as accurate as possible.
And does the decimal always have to have an M with it?
Not there yet. If you need text, string. One of the most common variable types. We have all kinds of stuff in the future, particularly when we start messing with databases, that is text. Names, addresses, states, zip codes, phone numbers, etc. I might as well mention, I'm not sure if I made it into the last recording, anything in programming that you don't do math with should be stored as text, like your student ID number. 8 digits, right? But what happens if I subtract his from his? Do I get anything? No. If I add them together, do I get an extra smart student? No. Nothing happens when you add student ID numbers. So it should best be stored as text. I don't know if it's my rule, but I claim it. If you don't do math with it, store it as text. Yesterday in my Excel class, some of you got to experience, wasn't that fun? In my Excel class yesterday, we saw that if you type in a number that has a leading 0 as a zip code, Excel strips off the leading 0. It's a zip code. You don't do math with it. You don't store it as a number. You store it as text. And that's what we did. We converted it to text. Same thing in all programming. So string, very popular type. Boolean for true-false fields. And this is not really a type. Technically, it's a class. There is no type for dates, but there's a bunch of pre-written code for dates. It's the date time class, and we use that quite a bit. So those are the most common types. When we want memory from our program, we declare a variable designating its type and then whatever name we picked for it. The names are that we described before in my notes. I skipped over it. Camel case. Letters and digits. Keep it simple. Descriptive, but not terribly long. What do I mean by terribly long? That's up to you. If you want nice, long, descriptive variable names, I have no problem with that. However, I will complain if they're too short and I can't recognize what they mean without thinking really hard. Mine are, I hope, reasonable names. Next bowling date is about as long as it gets, and that's not terribly long. Here's some examples. We didn't discuss these last time. We didn't get that far. String employee name. Employee name is going to be a string. If I'm going to process it, like store it into a database, store it into a text file, take it apart because this is the first and last name. Maybe you want to split it so I get the first and last name. Store it in a variable of type string. An employee's age is a whole number, so that's an integer. The number of hours they worked is probably might have decimal places. I worked 35.5 hours yesterday. Decimal places, that's a double because it's not money. Your hourly wage, however, is money, so you store that as a decimal as a decimal type. Is the employee married? That's either a yes or a no. Boolean field. That's an example. Probably not going to run into Boolean fields until at least Unit 5, maybe even 6, so don't worry too much about those. And finally, when was my employee hired? It's a date-time class. I'll make it simple and talk about it as a type. Okay. So those are examples of the 6 different types that you're likely to use and how to declare them. Notice our standards say for each one of these you must also include an inline comment that describes in further detail what that variable stores. Not how it's calculated or anything, where it comes from maybe, but notice my examples here. This is the employee name. Is that first name, last name, first name? The description helps. This one doesn't help much, right? Employee's age, but it's a little bit different. The number of hours the employee worked, I might have added to that if I didn't run out of the margin here in 1 week, right? Is that 1 week? Is that 1 day? My variable name doesn't make it very clear, but I could add a description that clarifies it. Or I could say weekly hours worked this week. I could stretch it out. Hourly wage, what do they make per hour? Are they married? And what date were they employed? All right, given that information, let's check over these checkpoints here on page 121. So I'm just going to open up my book here and take us there, and that way you don't have to worry about it. Problem is I can't get my slider because it's sitting on top of my recording. There we go. And I want to go to page 121. And down here are some checkpoints. What control can we use to gather text from the user? Not too tough. Text box. In code, how do you retrieve what the user typed in the text box? Which property is it stored in? Nope. Not string. Which property of a text box contains what the user typed? Text property. And we talked about that last time when we were clearing the text box. We cleared its text property. When we talked about text boxes, I said whatever the user types goes into the text property. And we can extract that, and we will. We're not there yet, but we can extract that from the text box when we need it. What type of data does a control's text property contain? What type of data? Of my 6 types, it contains a string, always. What if the user types in a bowling score in a text box? It's still a string. A text box always collects a string, always, regardless of what it looks like. We could type in a date in a text box, and guess what? It's not a date, it's text. It's SEPT 29, 2014. That's text. Text box collects text, period. It collects the string type data, period. If we want to use that as a number, we have to do some fancy programming, and we're going to learn how. But a text box always collects string type data. How do you clear it? We found 3 different ways, right? Let's look over here. Like, Kyle, give me one way to clear a text box.
Empty string.
Empty sign and empty string to what? I can't say text box equals the empty string.
Double quotes.
That's what the empty string is. Good, double quotes. But what do I got to do about the text box? Which property am I changing?
Dot text.
The dot text. Kyle, stop throwing your voice over there. It's not nice. All right. So text box dot text equals the empty string. Jeff, give me another one. How else can I clear out a text box? Help them out. Somebody, anybody. Dot clear. What else goes good? What else goes with the docs with the dot clear?
Just stop clear.
Parentheses at the end. So it's text box dot clear, and then there was one more. Anybody remember? Reset text. He's looking at it because here it is in my code. Reset text on a text box, clear a text box, or set it to the empty string. All three of those do exactly the same thing. Typically, I think I put the comment in here in my other class, pick one method and stick with it. If in your pseudocode it says clear the text box and you have to use .clear, right? No. Pseudocode is pseudocode. Translate it. If you translate it to this, that's good. That's fine. If your pseudocode says equals the empty string, I have to assign the empty, not really, but I would. As long as you translate it correctly, there's 3 different ways to translate that clear. Pick the one you like the best. Remember, I like to use the empty string because it works for labels and text boxes. So does reset text, but I don't like reset text. A label does not have a clear method associated with it. Just doesn't. So I like the empty string. Okay, so now back to my notes. See if I can figure this out. There we go. Questions about those checkpoints? That text property of a text box, very important. All right, last time we didn't talk too much about initializing variables. Okay, but C#, when you declare a variable, C# does not initialize it. Let's pretend you're running a program and the program says, go get me enough memory for an integer, right there. Windows looks around and says, I'm not using this memory over here. Okay, program, you can have it. We say, cool, I'm going to call that score 1. What's in that memory? Nothing yet. Reasonable answer, but wrong. It's a good way to think of it. What's in there is garbage. What was in that memory location the last time Windows used it? Who knows? What program was it assigned to? I don't know. It could have been the paint program. Might be pieces of somebody's hair. In binary, right? Maybe it was a calculator program and it could be the answer in binary. Maybe it was a Word document and it's a piece of a Word document clipboard. Who knows? We don't know. Windows does not clear it. When I'm saying I'm done with it, Windows says cool, it just puts it on its available memory list, but it doesn't clear it. The good news for you, you are so lucky, is that C# will not allow you to use a variable. What do I mean by use? On the right-hand side of an equal sign. I go back to my design here. Here I'm using score 1, score 2, score 3. Here I'm using the bowling date. Here I'm using the series. You cannot use a variable on the right-hand side of an equal sign until you've assigned it a value. Because C# knows, no, you can't use that, it's garbage. Why would you want to use the unknown garbage? You don't want to, C# won't let you. Other languages, the programming language, as soon as it gets the memory, erases it, not C#. The operating system doesn't do it. Other languages will do that for you, and then what do you get? Joni's answer, nothing, which by the way is different than 0, which is different than the empty string. That's not nothing. An empty string is a string with no characters. That's something. 0 is a byte with all the zeros set. It's the value 0. That's not nothing. In most programming languages, it's referred to as null. Literally nothing. Null. And that's where stuff starts. That's just about as good as garbage. Can't do much with null. So C# is smart enough to say, no, what if I skip these 4 steps here and said, take whatever's in score 1, 2, and 3 and add them up? There's garbage in there. Why do you want me to add garbage to more garbage to more garbage? C# will not let you do it. You'll actually get a syntax error saying that's not legal. You're so lucky. Can't tell you how many times I wrote programs and did math with garbage. What do you get when you add 1 to garbage? Garbage plus 1, and when you display it, you get garbage plus 1. You go, what? I just added 1. What happened? Right. You don't have to worry about that quite as much. C# also allows us, when we're declaring a variable, to initialize it immediately. So in my program right here, I could say score 1 equals 0. Could. I think it's a waste of time. Because what's the first thing I'm going to do down here later? I'm going to take what's in the text box and transfer it to score 1. What happens to my 0? It gets wiped out. So I don't do this very often unless I have a good reason. And most of the time I do not. So you can initialize variables right away. There's more examples coming. But I don't do that very often. Usually my program initializes them for me to something real instead of this arbitrary 0 value. The one exception to that is it's often a good idea to initialize a string variable when you declare it to the empty string. That's not bad. All the others often don't make a difference. Sometimes this is a good idea, but I don't always do that either. Here's some examples. Here I'm declaring a variable called program name, and I immediately assign it this value. This is called a string literal. We'll talk about it in a little bit, meaning literally an M and a little Y and a space and an F and an I and an R and so on. Take this piece of text, stick it into that string. Because remember, go from the right into the left. Take this number, which is a double. How do I know it's a double? It's got a 0.5 on it. And put that in the variable called hours worked immediately. My first question is why? What's magical about 42.5? You don't do these a lot. I'm just showing you how in case you see it. Okay. And here's what Joni was alluding to earlier. This is a decimal variable. If I make this 17.25 without that M, 17.25 is a double. By definition, that's how C# works. I don't think I mentioned it in this class that I didn't put it this way, but why do we use int and double instead of byte and float? Because these values, when you see them, 15, C# treats that as an integer. Not a double, not a byte, not a float, an integer. When it sees decimal places, it treats it as a double. Why? Because that's what the rules are. They're doubles. And since these are doubles, it makes it much easier to use the type double instead of the type float. The exception, however, is decimal. If I saw 17.25, C# would treat that as a double, and I want to say, no, this is a decimal number by putting an M on the end. Why M? Only thing I can think of, because it means money. Decimal is for money, right? M for money. I don't know if that's real, but that's what I'm thinking about.
Is there a difference between a capital M or a small m?
Yes, it's syntactically wrong to put a capital M there. It's a little m. Matt?
So does there always have to be an M to make it a decimal place?
Always, only on these numbers, okay? This is called a literal. This is literally 17.25.
So even if there's 3 decimal places?
Even if there's 3 decimal places, it's still a double.
Okay.
If you want it to be, and remember C#, I think I said this last time, C# is racist, right? It will not mix types. Prejudice, let's not say racist. Prejudice. Darn recording, sorry. It's prejudice. It does not mix types. Doesn't like to. There's some exceptions. We'll see them. All right. The double or the decimal type is the most prejudice of it all. It doesn't like any other numbers. If I try to put 15 in there, That means $15, right? 15. It goes, nope, that's an integer. I'm not talking to it. If I try to put 17.25, it said, nope, that's a double, not talking to it. Won't let you do it. Because in memory, they look completely different. Remember when we were looking at the different types here? A decimal takes up 16 digits of memory. And now I'm saying, take this little 4-byte integer and stick it into the 16 bytes of memory. How? Where? How does that work? It really ought to be able to figure that out, but it doesn't do it very well in C#. What's worse is, what if I say take this decimal number that is stored in 16 bytes and turn it into an integer? Wait a minute, an integer takes up 4 bytes. How am I going to take, imagine taking a gallon milk jug and say, put it in here. I can do it, right? If the milk jug isn't full, I can do it. But you need special permission in C# to do that kind of stuff. That's why it doesn't, that's why it's prejudice. Right? It's not, it just doesn't know how to take something that's huge, 16 bytes, and narrow it down into 4.
That's how it was raised.
That's how it was raised, yeah, exactly. It doesn't know how. It's called a narrowing conversion, taking something that's big and shrinking it. Inherently, it doesn't know how to do it. We can teach it, and we will, because there's times when we want to do that. But we have to tell it. Doesn't like mixed type math. We'll see that when we get to it a little bit later. Okay, what else we got here? Here's a Boolean. There's true and there's false. Also lowercase. C is case sensitive. And if you wish, you can declare a date time. And notice I set it to date time today. We already used that when we were clearing our date picker. This says, give me a variable called purchase date and immediately set it to today's date. Now that kind of makes sense. Kind of. If you wish, what if you don't want today's date? How do you get a different date? Oh, it gets a little more complicated. Here I'm declaring a birth date, and I wish that was my birth date, but here I'm declaring a variable called birth date, and I'm setting it equal to date time parentheses. Why? We'll explain that a little bit more in Programming Logic Intermediate. In the meantime, that's the syntax. If you want to set it to some other date, you say new date time. It creates poof, this new date time, and immediately sets the year to that, the month to that, and the days to that. You have to type it that way with the commas. Space is optional. But you have to put the year first, then the month, then the day. If you flip them around, you get some funky looking dates. Maybe even an error. Okay. So this is how you set a date time to a different date other than the current date. Current date is today. That's easy. Date time dot. But if you want a different date, you use new date time parentheses. Last time I did a recording, I couldn't remember how to do some stuff, remember? This is one of those. I'm going back to my notes. How do I initialize in C# a date to a different value than today? I'd have to go look it up in my notes. I don't expect you to memorize this stuff, but you should get a pretty good handle after a while of which chapter was that in. I know we talked about that. Which chapter was it in? Dates was chapter 4, tutorial 4. Then you go to my notes. Okay, if you're lucky, up at the top, if you're lucky, the keys work. Up at the top, there'll be a nice little index here that talks about dates and stuff. Unfortunately, there isn't. Not for that one, because I'm not creating an index for every term, but you can get close. In here, you should be able to search. Control F and just about any program lets you search, except this one is not listening to me. Oh, I'm sorry, that's the Mac version of the Explorer, so let's try Control F. There we go. And I can look for date time. And it found it here, and then I can go to the next one. And it found, oh, there's that one, and we go a little bit further, and right there, oh, found it. Just by searching. You don't have to scroll, it'll take forever. Check the index if it's, or the table of contents. If it's there, great. If it's not, then try the find feature. Control F if you're using a Windows device. In my case, I was using a Mac browser, so I did Command F. And I found it. All right. According to my instructions here, we're supposed to declare a bunch of variables. Right, now, I also said when we were looking at it earlier, how do I know which variables I need? From my design, everything that's on the left-hand side of the equal sign that is not an object, it's not a label or a text box or something. Anything that's on the left-hand side of an equal sign is a variable. So I'm going to need 1, 2, 3, 4, 5, 6, 7 variables. And now we have to declare them. You don't have to declare them all at once. You could declare them as you figure it out. But I already did, it's in my design. In my code, I like putting all my variable declarations at the beginning. We've already done 4 of the 7. We have the bowling date as a date time. And we have the 3 bowling scores. Notice the names came from the design, same names that I have in my design. Now I need a series, average, and next bowling date. So we just keep declaring more. You could put a blank line in here and put a comment and say, here's my output variables. Could. If you have a lot of variables, I've seen some people alphabetize them. It's nice, not necessary, shouldn't have terribly many. So next one I need, according to my design, is the series. What type? Int, double, decimal, string, Boolean, or date? English. Then if you don't remember which one of those, does the series have decimal places? No. Is it a number?
Yes.
Yes. That's usually my first question. Is it a number? Do I do math with it? We're going to add up. Right. Yes, it's a number. Okay, then there's really only 3. Int, double, decimal. Figuring out which one of those 3 shouldn't be too tough, right? Got decimal places? Yes. Is it money? No. Double. Yes, it's money. Decimal. No decimal places, integer. Every variable gets a description. So after you type it, immediately describe it. It's another one of those things you don't have to go back and do later. Your employer in the future may not require that. That's another evoker thing. I want to make sure you understand what that variable is storing, what's inside there, what will be inside there. And you don't have to say will store. That's what variables do. They store stuff. Just tell me what is stored inside. And maybe give me a little more detail that isn't included in the variable name itself. All right, we also need a variable called average.
Double.
Alan suggests a double because
Decimal.
it's got a decimal place and it's not money. Double, average, semicolon. Where do I designate that this is 1 decimal? You don't. Remember in our design, that didn't happen until we displayed it. When you do calculations, you rarely say, I want to do this calculation to the nearest 1 decimal place. Normally when you do calculations, give me all the decimal places. 25 decimal places you want to, fine, I'll take them. It's not till you display it to the human that we say they don't want to see 25 decimal places, they want to see 1. It's when you display that you format for 1 decimal place or 2 decimal places, and we'll talk about that next week. Maybe Thursday. Friday, thank you. I'll be here Thursday too. Be here all week. So it's not something you worry about when you're declaring the variable. You let the variable store as much as possible to be as accurate as possible. And then when you're done, then you do the display so that in the format that humans want it. It's a formatting for output, not for processing. All right, and this is the average of the 3 games. And finally, I need the next bowling date.
Date time.
Date time because it's a date. Wait a minute. Doesn't it go in a label? That's where it's outputted to. While I'm processing it, it's a date time. Oh, I hate when that happens. That happens when you're anal. But again, Yeah, look at these someday when they're not lined up. And tell me it looks as professional as it does when they are lined up. The green squiggles mean you haven't used these variables yet. Well, that seems like almost a duh, right? Because if I look at my design, where am I? I'm not even on line 2 yet. This is all overhead. It's not in the design. Variable declarations are not put in your design. It's a given. You got to do it. But you don't have to put it in your design. So there's no I haven't even started my design yet, so of course my variables haven't been used yet. If we're done with this method and we still got green squiggles, okay, now we got a variable that we didn't need. Like what? Like if you accidentally leave bowler name in there and you transfer or you don't transfer the bowler name in, it's never used. You might get a green squiggle that lasts forever. If you've got a green squiggle, it means you ask for a variable that you're not using. Either you forgot a command or you ask for a variable that you really don't need. Something's wrong with your thought process. Better figure this out. Easy answer is delete it, but why did you declare it in the first place? You must have been thinking about something. If you were wrong, then delete it. That's fine. All right, so there's our 3 or 5. Excuse me, let's try again. 7 variables. There's the 7 variables. All that is overhead. We haven't even hit the design yet. This one line is the beginning of our design. But we've got a couple other things to think about before we continue. This one's pretty straightforward. We took the value of the date picker. Remember, date pickers store the date you pick inside the value property. We transferred that to the bowling date because that's what my design says to do. Take the bowling, notice it doesn't say dot value, does it? Don't put that in there. That's C#. This, to most programmers, makes perfect sense. Take what's in the date picker, transfer it over here to the bowling date, to this variable. Don't put the dot values, the dot texts is in your design. That goes into the code when you translate this to C#. So we followed this, and remember, you might remember, it's probably in the other recording, I typed this exactly and said, not doing it, because this is a date time picker, and that's a date time. Prejudice. Can't. The date time is one thing. A picker is a whole nother. It's got that drop down and all the date things and the change the year and all that stuff in it. You can't blend the two. It's like turn this into one of these. What? No. Can't do it. So we had to translate. And I also said, thou shalt never be, you can, which you usually get an error, but thou shalt never mess with objects themselves. When you're writing code, it's not date time picker bowling date, DTP bowling date. Which component of the date time picker do you want to use in your code? What are you trying to do? Trying to get the date. That's in the value property. You need to know that. And you will. You'll learn it. If you forget, go back to the notes. Go back to the sample program. Excel class for me was kind of scary last night. I'm teaching them all this stuff and I said, okay, now go. And they went. They went all kinds of different directions. Same thing's going to happen here. I'm teaching you this stuff and then say, okay, now go write your programs. You go, wait a minute, how do I do it? Back to the sample, back to the notes, back to the recording. Everything you need, for the most part, is already in those recordings and in those notes. Just got to dig it out. Just as a bad example, I'm going to do this. Score 1 equals text score 1. No, that's an object. Which property of the object do I want? Text. Semicolon. No. Stupid C#. What's the problem? We can hover and it'll tell you if you can understand it. Cannot implicitly, that means automatic. Cannot automatically convert a string to an int. Prejudice. No, not really. How long can a string be? Huge. How big's a byte? Or how big's an integer? 4 bytes. How do I take this and turn it into 4 bytes? C# says, I'm not doing it automatically. You, Mr. or Ms. Programmer, got to tell me how. We're going to learn how. But it won't do it automatically. C# is type sensitive. Let's not say prejudiced or racist anymore. It's type sensitive. Doesn't like to mix types. Because when it does, it can cause side effects that you, the programmer, are not going to like. VB, Visual Basic, great for that. It'll do whatever you tell it to. If I put that in Visual Basic, go, yes, sir, and it just does it. And most of the time it works. It's that most of the time clause that causes you all kinds of trouble. Because when it doesn't work, it's really hard to figure out why. C# won't do it. If it does it and it doesn't work, we know whose fault it is, programmer. Because you told it to do it, you told it how to do it, and it didn't work. So we're going to have to leave that and fix it. But there's more in my notes before we get to that. In addition to variables, variable means it can change, right? As the program's running, we can change the value of series. Initially it's garbage, then we make it something else. Score 1, initially it's garbage, then we make it something else. We can change it multiple times in a program. It's a variable, we can change it. In addition to variables, programs also include constants. Constants are things that always are the same. They never change. First type of constants, there's 3 different kinds. First type of constants are called literals. Each type has its own literals except date time. In Visual Basic, even the date time class has its own literals. You put dates between pound signs and it recognizes them. But you have to know about the pound signs. Not so in C#. First, the most common type of literal is a string. This is literally a little s with a little u and a couple of r's, etc., 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 including the spaces. Those are all characters. That's a string literal. Every time I use that in my program, it'll result in the same thing. A little s, a little u, a couple of r's, and so on. Always results in the same thing. We'll use quite a few string literals. In your Unit 3 worksheet, it says, what do I surround those with? Quotation marks. Always. Not apostrophes, quotation marks. Other languages, they're interchangeable. Apostrophes or quotation marks, whichever one makes you happy today. Just make sure you start it and end it with the same thing. Here, C# quotation marks. There are Boolean literals, used a little less often. Only 2, true and false, lowercase. There are integer literals, 6. 1, 2, 3, 3. Notice there's no commas. There are never commas typed in your numbers in code. Never. But the user likes to see commas. We're going to show them commas. When we display stuff, we'll show them commas. If they type commas, we'll go, okay, well, my program doesn't like commas, so I'll strip those out and then turn it into a number. No programming languages like commas in their numbers, the language themselves. The new exception is Swift. It doesn't like commas either, but it lets you put an underscore in between. Boy, does that look stupid. 1_000 for 1,000. Okay, it's a little easier to read because when you're getting into millions, there's so many zeros that our brain can't sort it out. Is that 10 million or 100 million? Hard to tell. Underscores help, but not a whole lot. No commas. Whole numbers, no decimal places. They're integers. What if I need a byte literal? Then you better go look it up because I don't know how to do it. Never done it. I just use integers, not bytes. Doubles. Decimal places, decimal places. C# requires that there is 1 digit to the left of the decimal place, so you can't just type 0.5. You have to type 0.5. Those are the value 3.14159 always means the same thing when I see it in code. The number 5 always means the same thing. Literally 5. When will 5 be something other than 5? Never. It's a constant. It's a literal. What are we missing? Decimals. Decimal literals look a lot like doubles except with the M tacked on the end, that's all. And yes, most of the time it's necessary because the decimal type is type sensitive. It will not take a double and say, oh, I understand what that means and I'll deal with it. Won't do it. I find that annoying. Doesn't make sense to me. A double is smaller than a decimal. It ought to fit. All right, I can take a Dixie cup and put it in here, no problem. They're not exactly the same, but the contents will fit in here. I can't do the reverse. I understand that, but here, I don't understand it, but it's the fact of life. It's part of syntax in C# that you can't mix decimals with anything. C# also includes the opportunity for you to create what's called a named constant. This is a programmer-defined constant. That's different than a literal. What we're basically doing with a named constant, is assigning a name to this literal. I'm going to call this my first program. I'm going to call that program name. I'm going to call 0.05 the tax rate. And I'm going to call $75,000 the maximum salary. Might be euros, I suppose, but whatever. I'm going to give it a name. Why? Talk about it in a second. When you declare a constant, you do it like any other variable, except notice my capitalization. Why did I go all uppercase? So that I know as a programmer, this is a constant. I can't change it. It better not appear on the left-hand side of an equal sign. Can't. So it's a visual clue for me. C# doesn't care. Many programmers stick to camel case on that. How do I know it's a constant then? You don't. Put it on the left-hand side of an equal sign. C# will go, they ain't doing it, it's constant. So I use all uppercase. That's our standard. So guess what that means you're going to do? For all named constants, name them with an uppercase name. It makes them a little harder to read, right? Because Camelback helps us find the words. Put underscores in if it's really bad. But I think these are okay. Notice everything's the same, except there's a new keyword. That's a word. Why did they abbreviate it const instead of constant? Because this is left over from C, which was created way back when we tried to keep things short. So you add the const in front. That says this is a string variable. The capitalization does not make it a constant. That's just our standard. The const makes it a standard. Private is a scope indicator. We're going to talk about that here pretty soon. All right. A scope indicator. This one means that this is a constant that is only used by this form. Private belongs to this form, and other forms can't use it. In the far distant future, we'll create public constants that are available to everybody. But that's a long way down the road. So all of our constants, at least to start, will be private. So whenever you declare a constant, add the word private const to the beginning, and then declare it like anything else, and you must initialize it as you declare it. It's never going to change. You know what the value is going to be. Assign it right now. And you have to. If you leave the equal sign with this stuff off, C# complains. It's a way for us to name a literal. Notice our standard once again. Darn standards require that every constant get a description. What is this thing? Tax rate. Tax rate for who? For the county. Oh, okay. Couldn't I have called this county tax rate? Yes. Then this gets kind of redundant, right? Yes. But you and I are not going to get into the arguments about what's redundant and what's not. Give me a little more information in the description. Maximum employee salary, particularly if you abbreviate a little bit. Max, most people understand. When I go into my program, if I want to use these in formulas, I just use the names, not the numbers anymore. We'll see some examples as we get through it. Let me cover one more thing, then we'll take a break and come back and use these in our program. One third type of constant. There are literals, where you literally type the numbers in your program or the text in your program. There are named constants, where we assign names to those literals. And there are intrinsic constants. In this case, intrinsic means built-in. It's something that C# already knows. We've already seen some of those. We looked at the color class .red. It's an intrinsic constant. It's built in. It's part of an enumeration of colors. Somebody already coded it. What does red mean? Well, remember, all colors in computers are made up of certain parts red, certain parts green, certain parts blue, blended together to make 2 billion colors. When I say red, what does that mean? Well, I know, because I have a little bit of experience, that's 255 parts red, no blue, no green, done. Now we don't have to think about it. We just say, I want red, and poof, we get a sweatshirt that's red, or a background or text or whatever that's red. They're built into the language. We can't do anything about them except use them and hopefully find them and know they're there. You'll see all kinds of them as we go. You'll learn about the ones that are built in, at least the ones I know about. There's probably plenty of others I don't know about. So those are the 3 different kinds of constants. We'll focus on the first 2, literals and named constants, when we come back from break.